Okay, cool. I just see everyone here. We're turning this down real quick. All right, so we're going to start learning a new system of logic right now. Before we do, any questions or anything we need to go over before we get into some drastically new material? Okay, let's jump in. Okay, so far we have done this version of propositional logic. Right? What was the basic unit of propositional logic? The sentence, the whole sentence, the whole proposition. So we had sentence symbols like P. What else did we have? We had operators, right? And operators, what did they do? What were their job? They connected sentences. They're also called logical connectives. Yeah. So they connected propositions to one another. Right? Or in the case of negation, they negated an entire sentence, right? We also had some variables that I represented as shapes that were also in the book, like lowercase p and q and r, which could be any well-formed formula, but that's not that important. So the basic unit of propositional logic is the proposition. Now what we've seen over and over again is that the, see if I can get away with this with the mic. We've seen when we've tried to give arguments that the temptation over and over again is to give each letter to make it represent a particular person or object or a property. So we saw over and over again that we wanted to do, let's just say Pierce is wearing a vest, and that should in propositional logic just be P. Pierce is wearing a vest, right? But we've seen that we always end up being tempted to say Pierce is wearing a vest. If it's Pierce, then it's wearing a vest, right? But it's just not part of this language. This doesn't make sense in the language with that assignment, with that interpretation. This has to be the whole sentence, Pierce is wearing a vest, or maybe, I guess, you could do something like, at most, this would be the proposition, if Pierce exists, then Pierce is wearing a vest. But that's then false, right? Because I don't wear a vest most of the time. So I'm not at work or I'm not out. So propositional logic is very limited because it can't break things into subject and predicate, right? It can't be used to get any deeper than just a propositional level. But natural science, everyday life, is a lot deeper than just sentences, right? So you could think about propositional logic almost as a science of sentences and their relationships, namely, and their relationships of truth and falsity, right? But we need to be able to get a little bit more fine-grained than that in order to more precisely and also more naturally model and represent things like the structure of sentences, right? So this is just like one level where it takes a sentence as a whole, but like I just said, we all know that there's a deeper level of understanding within the sentences, right? That the sentence as a whole isn't the fundamental unit of meaning for human beings, right? So when I say Pierce is wearing a vest, That's not the fundamental level of meaning. You've got the meaning of the name Pierce, you've got the meaning of the name vest, then you have the meaning of the property, is wearing a vest, right? Or is vested, if you want to say that. And then how those connect to one another. So if you want to get a science or a model of human thought, you're going to have to penetrate deeper into the structure of the sentence. If we left it here, we would forever just be stuck at that kind of almost shallow level. Does that make sense? All right, and this is where predicate logic comes in. And of course, there's a bunch of different types of propositional logic. There are different kinds of predicate logic. The propositional logic we've been using is called piano notation. I think his name is spelled like that. I'm not sure. He was a early 20th century logician, and mathematician, and philosopher. And Bertrand Russell, I don't know if you've heard of Bertrand Russell, one of the most famous philosophers of the 20th century, 19th and early 20th century, attended some lectures by piano, I don't know, and was just like so amazed because Russell had been working on his own logic, and he went to a conference and basically saw that piano was using the notation that we've been learning, a simpler form of it that he invented, and was just blowing everybody out of the water. Like, his arguments were clearer, everything he said, Russell described it as like he had just this clarity of thought that no one else had. So Russell basically asked him at this conference, do you have a copy of everything you've ever written on logic? And Piano was like, yeah, I've got it all right here in my briefcase. And he gave him everything he'd ever written on logic. Russell read it at the conference in a few days, completely threw away his own logical system he was working on, and began working with a modified version of Piano system. And Russell popularized it, and that's what we have today, this type of logical system. But there's a bunch of other types of propositional logic, like that game I was showing you earlier, the logic game, like Polish notation. Well, let's just represent it like this. C. C would stand for the if-then, the arrow. And this would say A, then B. If A, then B, right? N would be negation, not A. Or A is not the case. A would be or. So A or B, right? This is not a very nice system, right? It's confusing. Our system of operators is clear. But the point is that there's way more than that. There's also Frege's system, if I'm remembering right. Yeah. What do you think this says? Have I showed you this before? Proposition A logically implies B. This is how you write A implies B. Here's how you say A, not A implies B. Here's how you say it's not the case that not A implies B. And that's how you say it's not the, right? Horrible. So imagine if you give an argument, his system of proofs, you'd have a diagram spanning the whole board for an argument, and you basically have to be playing a game where you're looking at the lines and connecting everything. It's horrible. Terrible. So there's a bunch of different logical systems just within propositional logic, and I'm just teaching you what I think is currently the best one and the most universally accepted. But now we're moving predicate logic, and something interesting about predicate logic is there are other systems of predicate logic, but because predicate logic was developed so much more recently, I mean, piano notation, what we've been learning, really only became widely accepted, I think, in the 1970s. So like this logic game I was showing you two earlier, this is a game from 1965. It's called Well-Formed Formulas, and it's just like a game to learn logic with. And the instruction manual is like a little textbook on logic. It's using Polish notation because most professors in 1965, think about it, You're in 1965, you're a professor at a good law school, that means you're probably like 50 years old. That means you were born in like 1910, and that's if you're a pretty young professor at these law schools, right? 50 is pretty young for a good job like that. You were born in about 1910. This system of logic had not been fully worked out yet. Bertrand Russell and other logicians were still trying to even just figure out an agreed upon way to do this stuff. There were like 8 logical systems they were working on. This comes along later as an expansion of this. And what's nice about it is if you learn how to do predicate logic, it's so much more universal than propositional. And it's really powerful because you'll get the symbols you learn in predicate logic will be used by mathematicians, they'll be used by philosophers, logicians. They will also end up being used in advanced types of computer sciences. So this is really like the gold standard of this class. Like this is the ultimate goal that we probably want to think in terms of. Does that make sense? And it's also the most universal. This has been kind of training wheels to get us to this. Make sense? Okay, so propositional logic takes the fundamental building blocks or the fundamental levels of meaning as propositions. Predicate logic takes the predicate as a fundamental unit of meaning. What is a predicate? It can be used as a noun or a verb. What is a predicate? Anybody have an idea? What does it mean to predicate something? So if I have, let's just say my subject is X, and I want to predicate something of the subject, what would that mean? Let's say I predicate X is blue. So X is blue. This is a predication. What do you think that means?
You're describing X.
You're describing X. How are you describing X? What are you doing in order to describe it? Is this X? No. So X is a thing. And you're saying, well, but X is this. Do you mean this is literally X is blue? Like, let's just say instead of X, I say Pierce, right? Am I the same thing as blue? No, but I'm wearing blue. We can even say Pierce is wearing blue. Am I the same thing as wearing blue? No. A lot of times we say is and we think it's, in its strictest sense, a definition of what a thing is, right? What it really is in itself. Like when we say cats are felines. That's saying what a cat is as a feline. This is attributing me a property, right? So properties attributed to subjects. Well, yeah, we'll go with that. So the property of wearing blue is attributed to me, right? Make sense? Purely grammatically, we're not going to talk about properties, we're going to talk about predicates. And we're not going to talk about objects, we're going to talk about subjects. If you look at, let's say, predicate to subject relationship, you all understand the grammatical function of saying, Pierce, the subject, is wearing blue, right? I'm attributing a predicate to a subject. The question is, that's a matter of grammar, but the property object distinction is a matter of metaphysics. If I give you, let's say this example, people are angry. In terms of subject and predicate, what's a subject? People is a subject. What's a predicate? Angry. Are angry. They're in a state of being angry, right? So it makes perfect sense in terms of subject-predicate distinction to see how this works. And that's how we're going to model it in logic. Okay, the problem is the people an object? Do the people really truly exist as an object? It depends who you ask. But if you say something like, look, the people of the United States, is that a material object that can have properties? Is it something that exists? In a sense, yes. In a sense, no. It's not a particular being with its own nature that exists in the world like we exist, right? If I say Eden, if I say Samantha, or if I say any of you, you are a concrete entity and you have certain properties. You're wearing a tan shirt. You're wearing a, man, am I colorblind? What color is that?
It's striped. It's just brown and white.
Striped, brown and white, something like that, yeah. You're wearing that, right? You all are breathing right now, hopefully. You're all thinking thoughts. Those are properties that belong to you, right? In the United States, we're all Americans, right? We're all here. Where are the people? Well, you're the people. All of us in the country are the people. But where is the object that is the collective group of all the people? Can you see it? Can you taste it? Can you sense it? So the question is, does it really exist as an object? And if it doesn't really exist as an object, can we give it properties? Does that make sense what I'm saying? So that's a metaphysical question. And I don't know how to answer them. Different philosophers will have different ontological or metaphysical theories about what really exists, right? But we can kind of be neutral on the issue of metaphysics, and we can instead just talk about subjects and predicates. Because if we started putting rules for how to symbolize the property-object relationship, you would have to have a whole metaphysical theory and system saying, well, these, like you, and you, you're objects, but the people are not objects. Congress is not a real thing, but the members of Congress are real. Do you see how if we wanted to base logic on that sort of metaphysical understanding, it would be impossible to get started because we would have to have 10,000 years of theorizing about what really exists. Does that make sense? So philosophers and logicians, we just kind of want to ignore that, and we're going to purely model or symbolize the grammatical relationship of subject and predicate, which could stand for the people, even though the people might not really exist. It's just a grammatical relationship. Does that make sense? Kind of what I'm getting at? I know it's complicated, but it's something that always confused me because, for instance, my professors would give me examples like, they'd say something like, the man over there, which is an object, is red, or the car over there is red. And my question was, hold on a second, if you understand modern physics and theory of light, you know that colors don't really exist as like out there, right? A color is a property that arises in the mind as a result of a complex amount of physical things happening and then being processed by the eye and then being processed by the brain, right? So colors don't exist out there. Wavelengths of light do, objects reflecting wavelengths of light do, but colors themselves are mental. Well, so if you say the car over there, which is a real object, has this color, how can you symbolize that as the subject-predicate relationship? Because it seems like whenever you say something like that, you're just wrong. So how do I know which things are real subjects, which things are real predicates I could use? And it wasn't until grad school when they explained to me, yeah, we don't care about that. We're just doing the grammatical stuff. But I mean, that has big consequences, right? If we were going to assume this. I mean, it would completely determine what we're allowed to say. Okay, sorry. Now let's get into more concrete stuff. So if we're just looking at the grammar, we have the subject, we have the predicate. The predicate is attributed to the subject. Now you can attribute multiple predicates to a subject, right? What we're going to do in this language is we're going to treat predicates as capital letters like P. Before, capital letters were propositions, right? So now we're going to say predicates are capital letters, subjects are lowercase letters. Let's say A, B, C, D, etc., right? All the way through to A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W. A through W are going to be, lowercase, are going to be particular subjects. Particular subjects. X, Y, Z are going to be variables. Let's just call them subject variables. What does that mean? What is the difference between a particular subject and a subject variable? What do you think that might mean? What is a variable?
Something that can like change. It doesn't have a defined thing.
Right. So it's a symbol that represents something, but it doesn't pick out a particular thing. Let's just say that particular subjects refer to something in particular, right? Subject variables stand for any general subject. It doesn't tell you what it is, but it stands for something, right? So these lowercase letters actually are basically just names, right? Okay, your name is no longer Samantha. You are A. You are B. C, D, and E. There's our class. Those are particular objects. That's bad B. So we've got capital letters representing the predicate. We've got our lowercase a through W representing individual things. Or I don't want to say things because that gets back to the metaphysics. Individual subjects. And then we have X, Y, and Z as our variables. Okay. The whole proposition is formed out of these relationships. So if I was going to diagram this, I'll say prop for proposition. This is where propositional logic stops. Predicate logic goes further and divides it into subject and predicate. But then it also has to do what? What does it have to give us other than subject and predicate? So say I give you a sentence, Pierce is wearing a vest. Well, that's just subject and predicate, right? But what if I say, if Pierce is wearing a vest, then Pierce is sweating or something, which is true. What would I then need to fill in the gap? There. Pierce is wearing a vest, that's subject and predicate. Then Pierce is sweating, which is another subject and predicate statement, right? What do I need? Operators, right? Connectives. So you can see how it's going a level deeper, right? Now, why throw out what we've already learned and developed with all of our operators, right? Those operators connect propositions. Well, if a simple proposition now in predicate logic is subject and predicate, can't we just use the operators to connect these now. We're just symbolizing different. So we're going to keep the same exact operators, right? We're just going to represent propositions as broken into parts now. And here's how I'm going to write it. Do you remember your names, your new names? A, B, C, D, E. Let's say E is wearing a hat, right? Is wearing a hat. How would I say that? In this notation, H will be the property of wearing a hat. E will be you, right? E is wearing a hat. E is sitting to the right of D. Sitting to the right of? E is sitting to the right of D. You read it in this order. E has a relationship R to D. Does that make sense? Somebody give me another one. Tell me how to symbolize it. Any statement at all.
B's wearing glasses.
He's wearing glasses. How do you want to symbolize that?
G. B.
Good. Here's a fun one. Oh, wait, come on. I gotta put myself, I'm so bad at spatial reasoning. Okay. What about is to the right of? So if I start with A, I could say a 5-place predicate. Right? You can stack them. So this is a 1-place predicate, and that just means it just applies to one thing. This is a relational predicate, right? E is to the right of D, so it's 2-place. But you can have relationships between a bunch of different things, right? Maybe we could take this as A is to the right of B. Well, A is to the right of B, is to the right of C, is to the right of D, is to the right of E, or something like that, right? Which, well, actually, we'd have to do left, right? And you can have these crazy long predicates. They're multi-place predicates, right, that symbolize relationships. So maybe if our metaphysics are a certain way, when I talk about the people of the United States, I end up representing that as a multi-million place relationship predicate between all the people in the country, right? So it gets complicated. So we've got subject, we've got predicate, we've got operators like I showed you, right? Is this making sense so far? Our vocabulary? All right. In propositional logic, if I wanted to say all cats are mammals, I would just use one sentence, right? One symbol. That's one proposition. Or I could break it into two and say, if it's true that this thing is a cat, so the proposition this thing is a cat, then this thing is a mammal. But if I want to speak generally about all, and say all cats are mammals, how would I do that with this predicate logic that I've described? How would I say all? So let's just say this particular cat C is a mammal. How would I say all cats are mammals? This just says this particular cat is a mammal, right? How could I say all cats are mammals? Could I do it in this language? I could maybe try to use a variable. Something X is a mammal, but then how do I know that that's a cat? And now I'm just saying something is a mammal. That doesn't really mean much. It's just some indeterminate object is a mammal. What I have to introduce is now not just operators, but quantifiers. What is a quantity? What is a quantity?
Like
A number, an amount, right? A quantifier is going to be a logical device that allows us to number things, or allows us to speak about all, or some, 2 or 3, right? That make sense? So, in English, the quantifiers that we typically have are like all, some, 1, 2, 3, 4 of them, right? In predicate logic, so we don't get super complicated, we're just going to have these quantifiers. We're going to have a universal quantifier, which is written as just in this book in X, or as an upside down AX. That universal quantifier says everything that is an X. So for any object X, does that make sense? Not a particular object, it's saying for all things X. Then we have the existential quantifier, which is the backwards E with an X. And this says there exists an X. So universal says all X's, existential says there exists or there is at least one X. Okay. I know this is getting this is like already double the amount of like, well, I guess you're adding 3 onto it, so it's more than double. You got a lot more parts in play here, right? This is a much more complicated logical system. We've got subject, predicate, quantifiers, operators. I guess we can also say, we can even further split subject up into variable and name, right? Look at how it's kind of nice, like you're getting a whole model of like human thought and language. Okay, so I said earlier, let's just say this particular cat is a mammal. Let's just say this cat is my cat, Flipper, right? Flipper is a mammal. If I want to say all cats are mammals, what I have to do is I have to say for any X or all X's, if it is a cat, if X has the property of being a cat, then X has the property of being a mammal. Does that make sense? Now, C here is my particular cat, Flipper. I'll change it to F to make it more clear. But here, we're talking about cats being a property. Being a cat is a property of that animal I call Flipper that is in my house, right? Just like being a human is a property of all of you, I think. And I could write this either upside down X or what, right? Or upside down AX. So this says, for anything X, if X is C, or has property C, then X is M, or has property M. Right? We say is, we say has. The way we use those, they're all forms of the verb to be. Right? I don't know if you ever heard that. Like, the verb to be can mean a bunch of different things. It can mean, because in Greek, how we think about being and properties derives from Greek philosophy, even our common language. In Greek, you have the word to be is toenai. It just means to be. And then you have all these different forms that mean this thing is, this thing exists, this thing has this property, this thing is functioning in this way, this thing. So to be in English has all these different meanings. Like, so when I say is, I'm not talking about identity, I'm talking about has a property. Does that make sense what I'm saying? A bunch of different forms of to be. Okay, so for anything X, if X is C, then X is M. What would this say?
There exists an X where, or there exists some
Yes, there is something. Now when we say something, it's the combination of two words is some, which means what? What does some mean?
An amount.
An amount. Does it say what amount?
At least one.
At least one, right. There is some, at least one, thing that exists. A thing is a thing that exists. There is at least one thing that exists, X, such that X is a cat and X is a mammal. Make sense? What would this say?
There exists a thing, X. If this thing exists, it has the property of C, it has the property of
Good, yeah.
So it just makes sense.
Oh, you're good, you're good. Yeah, if, or I'm sorry, not if, yeah. There exists at least one thing X. We don't know what it is. We don't know how many there are. We just know there's at least one X that fits this description. There is at least one thing X, such that if X was a cat, then X would be a mammal. Do you see how these two are now completely different propositions? This one says, for any X, if X is a cat, then X is a mammal, right? This one says, there's at least one X where if X is a cat, then X is a mammal. If you just had this, you would not know that all cats are mammals, would you? You just know there's at least one. If there was a cat, then it would be a mammal. But maybe there are some cats that don't follow this rule, because this isn't saying all, it's just saying at least one.
Sorry, does that bottom example, does that start out with an if, or does it start out with a there exists one?
It starts out with the quantifier, yeah. So you read this quantifier first.
So you don't read it as if there exists one cat, you read it as there does exist one cat.
Yes, there is at least one X, such that if X is a cat, then X is a mammal, yeah. Good. Yeah, that quantifier is, it's changing how we parse or gloss these forms. Because before, it was just a proposition, if P, then Q. Now we've got this whole other element of, oh, now we've got quantities involved. And now we've got subject and predicate involved. This is like so much more complicated. But I think it's more natural. It's just natural thought's way more complicated than a simplistic propositional model. Okay, so is this making sense how I'm symbolizing these things? Okay, so let me just do a quick recap. In predicate logic, we have names. I don't remember what the book calls them. Has anybody read this chapter yet? Subject symbols for particular subjects. We have variables for subjects. We have predicate symbols. We have our normal operators. And then we have quantifiers. I'm sure we also have a well-formed formula rule, right? So our well-formed formula rule is, I always teach this intuitively because it's harder to explain than to just teach intuitively. You all know how to do well-formed formulas by now in propositional. The only difference is, so within the parentheses, the same rules apply. There has to be a left and a right. But now the left and the right is just going to be think of it as this thing's the entire proposition, right? X is C. So there has to be a left and a right. But part of the well-formed is if you have a quantifier, it has to be outside of this, on the left. And this quantifier has to be touching the parentheses so that it ranges over everything in it. It ranges over all the x's. So let me show you this intuitively, hopefully. If I say for any x, x is p and x is q, and x is w. This whole statement, this compound proposition, is bracketed by itself. Do you see that? So this one says for any x, x is p and x is q. This just says xw. That's not well formed. This quantifier does not apply to this. Why?
It's inside the bracket.
It's inside the bracket. How would I make it apply to all of those?
If you move the bracket over, left it outside.
Good. So part of our well-formed formula rules for the quantifiers is that whatever we want them to range over, the x's or the variables, they have to be touching, like the whole thing has to be bracketed and the quantifier has to be touching it. Does that make sense? Those brackets, you can almost think of it like completing a circuit. The quantifier touches the brackets and flows through the entire thing. So one restriction we have is you can't have a free variable. A free variable is a variable like we saw earlier. That's not, it's a variable, but it's not constrained by an operator or a quantifier. Does that make sense? Whenever you have a variable, x, y, or z, you have to have a quantifier attached to it. Because what does it mean? If x doesn't mean anything in particular, it doesn't refer to any particular subject, what does it mean for me to just say x is w? It doesn't mean anything, right? At all. But when I now attach a quantifier to it and say, for anything that exists, that thing is w, that makes sense. An existential quantifier, there is at least one subject that exists that is w. That makes sense. But just me saying x is w, what the hell is that supposed to mean, right? So that's our restriction. Does that restriction make sense? Okay. So you can't have a free variable. Let's just intuitively do this example. Is this a well-formed formula in terms of what I just described?
It would be if, I don't know how to write it, but it would be if for the quantifier you had the upside down A and something that included the Y as well as the X.
Right, good. These y's don't have anything quantifying them. They're still variables. So we've got to somehow make a quantifier to capture a range over these. How can we do it? This is how the book will write these things. I like the upside down A, but the book just has X and Y for the universal. What would this say? Now it's well formed, but what does it mean? That I now have two quantifiers, which I could disambiguate like this. Right.
So is that saying for all X's that exist, if they have P then they have Q, or for all Y's that exist, if they have T then they have Q?
Good, yeah. So this is telling you that these variables stand for anything at all, anything that exists in our universe. And so they're now ranging over, yeah, so for any x and for any y, if x is p, then x is q, or if y is t, then y is b. Yeah, so you're absolutely right.
So just the way you write that for all, you can just either do X, Y, you can do upside down A, X, upside
You can even do upside down x, y like that. Doesn't matter. Yeah. But do you see now how you can stack quantifiers in order to make them well-formed? This is where it gets even more complicated. I'm just trying to survey everything to show you how this language works all at once, but we're going to have to learn this in steps to get good at it. What happens if I say, for any x, there exists a y, such as x is p, then y is q? What does this mean? I know I just said it, I glossed it, but what does that mean?
For every x, there's a p. If for every x there's a p, then there's at least one case where y is q.
Close, but not quite. So your guess was, if all x's are p, then y, there is a y that will be q. Not quite. Does anybody have another shot at it?
Would it be for all x's that exist, there exists one y, and if that x that exists as a p, then y is a q?
Yeah, got it. So it's saying, for any x, there will exist at least one thing y, such that whenever x is p, then y will be q. Yeah. It's not, is it saying that there exists a y? No. It's saying, for any x, if x was p, then at least one y would be q. But we do not know if there are anything that exists in our universe, just from this, right? So there might not be any x's, and therefore there's no reason to think there's any y's. Okay. What's that? I reversed the quantifiers. What does this say?
There exists an x. There exists an x such that if x has property p, then all y have property q.
Is that right? There exists an x, but if x is p, then all y has q. That might be correct in meaning. Let me gloss it the way I gloss it, and see if it's the same. There is at least one thing x, such that for any y, if x is p, then y is q. Yeah. So I think in meaning it would be the same as what you said. Yeah. Good. Complicated shit. The book isn't that mean to you. If you get into more advanced logic, which, raise your hand if you think you'll ever get into more advanced logic. One, yeah. So for you, you will probably need more variables. You will have to invent them. This book will, I think, only gives us an x, y, and z, and to keep it simple. But sometimes you need a lot more, and you also then need variables for predicates, and not just particular predicates, right? But I'm going to stick to just these three. Okay, if I say x, y, which universal, right? Existential, z, and then I say x is p, and y is q, then z is h. How could I gloss this? This is hard.
This is probably wrong. But if all x and all y, then if x is p and y is q, then there exists a z that is h.
Good, yeah, exactly. For any x and for any y, it's basically saying for any objects, x and y, this is going to be true. For any x and y, there exists a z such that if x is p and y is q, then z is h. Which means if we have two objects, or even just one object under different names, if we have two things x and y, no matter what they are, and they fulfill p and q, they have those properties, then there exists a z that has h. Does it mean there exists a z that has h? Mm-mm. It's just saying if there are at least, if some object, any object fulfilled this, then there would be a z that had h. But maybe we don't have objects fulfilling that. This is complicated. This is very complicated. The guy who I took the job from at OSU, as a graduate student in the MA program here in philosophy, you have to take this class, and then you can move on to do more advanced logic and independent studies. And he gave this really hard test with predicate logic and was like, you have to pass this test in order to test out of this and go straight to more advanced logic. And I passed it my first try because I've been doing this for so long. And he was like, wow, like I made that test so you can fail it, like, because I don't want anybody testing out of this class. And I was thinking back to this, I'm like, how do you expect anyone to test out of like this from undergrad without having taken this class? Because I took this class and did like graduate independent studies in undergrad, that's why I could test out of it. But he was basically having people come straight out of undergrad and doing all of this stuff and had to be super fluent in it. And then I realized like, oh, he just didn't want anyone to test out of the class, test out of this class as a graduate student at all. It's crazy. This stuff is really hard. I mean, I say that not just to aggrandize myself, even though I guess I am boasting a little bit, but this stuff is like hard. It takes a long time to get good at this, and there's a lot of different meanings these things could have. So do not get discouraged as we go through this. By the time I was out of undergrad, I had taken 3 more logic classes than you guys. So I had intro to logic, logic critical thinking, symbolic logic, advanced logic, inductive logic, independent study on logic. I did a lot of logic. And I only got good at this my last year in undergrad, my last semester in undergrad. So if this is hard and stressful, please do not be discouraged. I literally did nothing else. Okay? And if you want to get super good, you should do nothing else too. Okay, does that make sense? I know people watching this are gonna like freak out at all the stuff I put on the board so far. That's gonna stress a lot of us out. Please don't be stressed. It's okay. It'll get easier and it'll get simpler. Okay, how much time do I got? It's 11:23. We got 11:45. Okay, I'm going to put some practice sentences up on the board, and I want us to translate them. Cat is fat. The cat is in my hat. The cat has a hat. The hat is red. The car is fast and ugly monkey is named Robert. Yeah, let's go with these. Okay. Actually, hold on. I'll put a few more. Okay, let's start with the easy ones. The cat is fat. How do I symbolize that?
Capital F, C,
What's F stand for?
to be found.
Ah, to be fat. I like the to be. Philosophers in English, if you read Greek, Greek is an awesome language, extremely technical. You've got all these forms to be, and Greek does not flow like English does, where we say, this subject has this property. It's more like this subject, and the words will sound similar. It's almost like if we were saying, this subject to be this property, except we had changed the end of the word to be slightly, and it would indicate exactly what we meant by to be. That's why Greek is awesome. For each word, there's so many different conjugations. Greek is almost like a logical system in itself. It's a cool language. Okay, but so for this, philosophers will often make up words in English called, it doesn't work so well for fat, because you can just say being fat or is fat, but for things like red, we can say has the property of redness, right? Has the property of fatness, has the property of ugliness, has the property of wearing a hat, or maybe even hat wearingness, because some of the properties get really awkward, and we don't want them to confuse people and sound like I'm saying that this somehow is what this person is, or you want to distinguish the different kinds of properties, because there's a shit ton of different kinds of properties, and they're all very different kinds of things. Having a color is a lot different thing from being fat. That is a lot different thing from being blue emotionally. Properties are like, predicates and properties are not one kind of thing, right? Does that make sense? So we have to talk about them in a weird way sometimes. Anyway, okay, how do I say the cat is in my hat?
You could just do H with a little C.
Good. Well, wait, hold on. Say that again.
You could do a big H with a little C.
So, what would that say?
What do you mean?
So this would say the cat, right? Particular cat, C. The cat is in H. What would the property H stand for?
Is in my hat.
Is in my hat. Isn't there another subject here? Me. My hat. And then the hat itself. It's a definite hat. So this is actually saying, now you could just define the property is inside my hat as H. But really, this is a multi-place predicate because it's a definite hat, it's a definite cat, and I'm a definite person, me. 3 subjects. Cat, M for me, hat, for my particular hat. Relationship, I. And then you'd have to define this relationship as the relationship of being in, C is inside what M possesses of H or something like that. Or you could just be simpler and say the cat is in my hat. It's fine at this level if you just do HC. Does that make sense? Okay, what about the cat has a hat? What's a definite subject here? The particular.
So actually, question back to the first one, because of the word D implies that there is a cat. So would that be the reverse E?
So when you say the, you mean you are picking up a particular thing. So when I say the guy wearing a Walmart mask and black baseball cap, that's you, right? That whole sentence, the description is basically a new name for you, right? So when we say the, we're talking about a particular object, so we're just talking about, a particular cat, even if we don't name the cat. It's the same thing as me saying my cat Ian or my cat Flipper. Particular cats, I'm just indirectly describing that particular thing. Does that make sense?
Yeah.
So now that applies here. It's still the cat, so it's a definite cat. Particular, so we're going to say C for that cat. What about has a hat? Is the hat a particular hat? Is it picking out any single hat, or is it general? Just some hat, right? Does that make sense what I'm saying? The cat has a hat. I'm not telling you which one he's got. I'm just telling you he's got some hat. Does that kind of make sense? It's weird. But we'd end up symbolizing it as there exists an X such that X is a hat and that particular cat C, S is just a property of possessing, let's say, has X. There exists an X such that X is a hat and C possesses X. Does that make sense? This seems a lot trickier. Like, what we want to say is just that, oh, the cat has a hat. But this is so much more complicated than it seems at first, right? Because we don't want to just define properties like, that's a big-ass property, has a hat. Isn't that having something is a multi-parted relationship between multiple objects, right? I have my class, I have my students. That means I have a relationship to each one of you. I wouldn't just want to define, Pierce has 5 students in the room as, right. I would want to specify I have 5 students in the room and really break it apart into its smallest units. Does that make sense? Okay, let's move quick before we run out of time. We've got 10 minutes left. 11:45, right? Okay. The hat is red. Is it a particular object? The hat? Yes. The property of being red. How should we write this? The hat is red, or has the property of being red.
Is it just RH?
Good. RH for that particular hat. Now, this is where it becomes interesting. If you think that this, remember how I said, we don't want to define the property has a hat as just H, because that doesn't really represent what having a hat is. So now I'm kind of talking metaphysics of like, what is the relationship of having a hat? And I want you to more accurately represent the relationship of having a hat, breaking into its parts. if you don't think that we should, if you think light's very complicated and color's very complicated, to say this, really, you might want to actually give some sort of big expression that's like, the particular hat stands in this relationship between wavelengths of light, the angle of the sun, and an observer's eye being processed. Do you get what I'm saying? You don't have to do that in this class, but that's at least like one of the cool things that this can do. It can get very specific. Okay, the car is fast and ugly. The car is fast and the car is ugly. Ask yourself this, particular or general subject?
It's
Particular, the car, right? What are its two properties?
Fast and
Being fast and being ugly, good. How can I symbolize that?
It would be capital F fast, or AC dot, then capital U, and then lowercase c.
Good. C is fast and C is ugly, where C is this particular car.
Another question, if you were to change the first part of the sentence to that car, that would be when you would use the reverse U, because then you're referring to one specific car, right?
No, so this is referring to one specific car too. So that and the, think of it this way. A particular thing is when I pick out with my words and I'm in a way pointing to it. So when I say the man in the Walmart mask, that's a way in words of going, you. If I say that man in the Walmart mask, right? It's a more intelligent way of just doing that. So when you have that backwards E, that's when you're not picking anything in particular out. When you're not doing that. You're just saying, there's something. If I just said, there is somebody in the building with a Walmart mask.
I was doing the two in reverse, okay, I get it.
Does that make sense?
Yeah.
Yeah. Okay. The ugly monkey is named Robert. The ugly monkey is named Robert. Particular or general? Am I picking something particular out? What is it? The monkey. Let's just say R, because we know his name is Robert, right? The monkey Robert, R. Now, what is the property here?
ugly.
Ugly is the first one, so you say you are, so this monkey Robert is ugly. And what's the other property?
named Robert.
His name Robert. Let's just say N R. Having a name, do you see how like when we're assigning letters to things, we're giving things names, right? So being given a name is itself a property. Now when I just say Pierce, that name points to me. But when I want to talk about, well, why did my parents name me this? I start then talking about the property between, the relationship between a word and myself and how they're associated. So yeah, so this says monkey R is ugly and monkey R is named Robert. Make sense? Okay. What if I said all cats are fat? Particular subject or general? Raise your hand if you think it's particular. Raise your hand if you think it's general. Okay. So we know it's going to be a variable, x, or y or z, whatever. Now if I say cats, is that a subject or a property? Now, if I'm saying all cats, I think that I should be cx. So I'm saying anything that has the property of being a cat. Does that make sense? What's the other property?
Fat.
Fat. How do I join them together?
Use the arrow.
Arrow. Little sign under the. Okay, so this says right now, if X is a cat, then X is fat. But that's not well formed, right? We need a quantifier. We can't have any free variables, right? What quantifier would I use? Universal or existential? What?
The upside down A.
Upside down A. Or just in the book, just that X, yeah. For any X at all, if X is a cat, then X is fat. In other words, saying all cats are fat. All things that are cat are fat. Make sense? Okay. If any boy is blue, then they are ugly. If any boy is blue, then they are ugly. Is this a particular subject or general? General. So we know we're going to have a variable, let's say X, for our thing. What's the first property?
X is a boy.
X is a boy. Being a boy. So X is boy. What's the next property? Blue. I'm going to put M. Although boy is a gender thing, M is a sex thing. So don't cancel me for getting those two things confused, please. It's just for the symbols. Okay. So X is a boy. X is blue. Then they're ugly. You. How do I connect these things together?
The and for the boy and blue.
Good, boy and blue. If X is M and X is B, then what symbol is that? X is U? Good. Now, any and all, same word. Any and all are the same. So what quantifier would that be? Universal, good. Gloss this for me. Well, okay. I need one more pair of parentheses, right? Because I gotta make this capture everything that it touches. Range over. So someone gloss this for me. What does this say in symbols? So just read the symbols. Don't worry about the properties, just the symbols themselves. How would you say that?
For all X, if X has property M and X has property B, then X has property U.
Beautiful. Make sense? Okay, last two. If Robert eats the salad, then the salad had ranch. Use, I guess, ranch on it. Whatever. You know what I mean. Okay, let's ask. Robert, particular or general subject? Particular. This guy, Robert, eats the salad. What property is that? How would we represent that? Sure, let's have eat. Well, but what's he eating? The salad. Is the salad particular or general? Particular. I'm talking about that salad. The salad. That one. Let's say S for that salad. Robert eats the salad. Okay. Then, which is an arrow. So if Robert eats the salad, then the salad, which is S, had ranch on it? R. Salad has ranch. Now you could break this apart further and say there is something X such that X is ranch and the salad has a certain relationship with that thing that is right. But just for our purposes, just put RS, right? Do I need any quantifiers here? Is there any free variables? No, so I don't need quantifiers. That's all I said. Okay, last one, then we'll go. If Robert eats a salad, then the salad had ranch on it. Robert still And we've got eating. But what about a salad? Is that particular or general? General. See subtle difference between V and A, right? So that's now going to be a variable. It's going to be R8X. And I'll just do it because we're out of time. There exists an X such that Robert 8X, oh sorry, I fucked it up. Okay, sorry. There exists an X such that if Robert eats X and X is a salad, then X had ranch on it. Does that make sense? Literally, one word change from D to A, completely different formula. Make sense? Okay, good luck with this stuff. Class dismissed. Again, do not get discouraged. This stuff is complicated, this stuff is hard. The point of my story earlier was not necessarily to boast, but to tell you that people who are done with undergrad, who take philosophy seriously, and have taken logic classes, cannot test out of OSU's logic fit ordinarily. So don't feel bad if you can't get this immediately. Got it? All right, bye everybody.